Hello everyone, my name is Palma Laterza and I am the test leader of a refined digital first storyline. This is the acquisition and upgrade of an existing railway line. A refined storyline focuses on the representation as is of a railway line that is currently managed by another company. And RFI is in fact interested in knowing the existing condition of the line to be able to identify the infrastructural gap with the RFI standards and later to see if an upgrade is possible and how much it will cost. For this storyline, we are in the planning phase and some use cases have been identified. Existing condition model, railway design modeling, in particular the feasibility study for railway, the 3D visualization, and the quantity takeoff. To test the storyline, the entire process has been divided in 3 phases. For each phase, the following process was established. RFI collects the requirements and provides input to the software vendors. The software vendors uses the input to produce an IFC model and other material if required. The output is then checked and validated by RFI using also an automatic validation tool. The validated model is then used as the base for the following phase. This table shows inputs and outputs for each of the 3 phases. In phase 1, for the creation of an alignment model by the software vendors, RFI provided some input data, such as computational specification, a landing XML, and a parameters table for alignment and some spatial structures indication. The alignment model produced was then used as input for phase 2. Together with datasets for track elements and quantity takeoff requirements. The elements were sleeper, ballast, and rail. The track model produced in phase 2 is then used as input for phase 3, together with a dataset for some elements, such as cables, ducts, cantilevers, signals, etc., and quantity takeoff requirements for these elements. Now we have accomplished phase 2 and we have received the IFC files from akka, Recomplete, and 12D. Now let's take a look at one of these files. The file I'm showing was produced by akka for the milestone of phase 2 and it contains the track model. Now we are using the akka IFC 4.3 viewer to look first at the alignment of the railway with all its segments and the information associated. If we want to check the track elements, we can zoom in and find the section with added elements. We can see here ballast, rail, and sleepers. For each of them, we have some information, including shape, representation, and associated properties. The first visual validation is then followed by an automatic validation. This is a tool that checks if IFC model against a computational specification. We create this specification by adding some rules that check correct parameters and tolerances for vertical and horizontal alignment. The correct alignment and decomposition, that the requested piece sets are associated to the elements and that they contain the requested properties, that the properties have the requested values. From there, we use the specification to check the file as the akka file in the example. A report is produced, then it can be shared with the software vendors. That is all for now. Thank you for your watching.
Hi, my name is Marianne Schenkman and I'm from the Finnish Transport Infrastructure Agency. We will present you the Nordic Storyline level crossing detailed design. And for this storyline test, we have chosen a real case, the Toivola level crossing, which is located in central Finland. Prior to the improvement in 2020, this level crossing was actually one of the most dangerous ones in Finland. The road had a very unfavorable crossing angle in the original layout. The improvement project, it included road, railway, signaling, technical cabin, cabling, snowplow protection and similar, so quite a big variety of subdomains. Here's our storyline team. So we have representatives from the Finnish Transport Infrastructure Agency as well as from Trafikverket. Our technical experts were Lars Wikström and Juha Hyvärinen, and we had several software vendors participating, from which akka and dussel were the most active ones in the testing phase. The dataset included, for example, geometries as LandXML files, as well as service models, also LandXML files. And the signaling objects like the cabin, boom barriers, axle counters, and so on were provided as 3D DVGs. Also, we had several Excel files and such. These drainage and road data, that's in parentheses because they were excluded from this storyline, but they were used in the IFC infra deployment project.
This is Lars Wikström representing IFC Rail Technical Services and Triona. From the perspective of the test team, we have identified a number of values and good things for us as a test team. First of all, of course, doing schema validation based on a real case storyline and making sure that the schema is fit for purpose is very valuable. The work that we do provides a great input for defining MBDs later on. And of course, it has been a great learning experience for us as a team, learn IFC for infra from the inside. And of course, meeting up and working together with the software vendors, seeing what they are capable of and learning from them has been also very valuable for us. As a team, the stakeholders, technical experts and software vendors, we have worked together in a Github environment where all material has been shared. So the data from the stakeholder that Marianne just showed is available for all participants. We have from Rail Technical Services provided a reference file, which is sort of a template for the data that we would like to see from the software implementers. And also the software implementers themselves can share their data on the same repository. And also here is material where we have made prioritizations from the perspective of the stakeholders, what objects to include in different groups, so to say. From this, the software vendors has worked, and we have a few video clips, one from akka that I will show now, and later on a clip from dussel. So let's start with akka. And akka actually produced a file that contains already much of the data provided by the stakeholder. So here we see the track structure with a ballast and sleepers and rail in IFC format, and going into the level crossing itself, we can see the boom barrier with all its components like signals and signs. and things like that. And then they can export this file. And in the later video, we can see that dussel can import the same file and use it in their software system. And now we move over to a short video clip from dussel. Started here. And dussel imported the file that was created by akka. And here we see they are just checking that the different elements are here. For example, a railway track sleeper. And they export the file again and show in another software, in this case BIM Vision, that all the data is there again.
Hello, my name is Peter Axelsson and I work at Trafikverket in Sweden. As infrastructure managers, the release of IFC 4.3 is essential in many aspects. We see this as one of the main factors to be able to have a true machine-to-machine management of asset information in order to get rid of different documents and Excel sheets and this kind of information transfer. We also see that it will facilitate the communication between system and actors in a much better way than what we have today. And it also enables a transparent requirement management. We will be able to require information in a standardized way with an international standard behind. This will also increase the international competition, since we can have more actors entering the arena, and it will reduce the cost in a life cycle perspective. The level crossing storyline is of special interest to us also, since it combines both rail and road asset information. We do have many existing level crossing that need to be updated, even though we don't build that many new ones. And the track alignment, which is part of the level crossing dataset, is difficult to handle, but a very fundamental issue. So these are some of the reasons why we participate in this work and think that it is important. Thank you.
Hello everybody, my name is Ashraf Tool from SNCF, and on behalf of the ERTMS Storyline test team, please let me give you an overview on this storyline. So I will begin by outlining the purposes behind this test case. So as you know, ERTMS technology relies on two systems belonging to two different domains. We have GSMR mobile telecommunication network, and we have a signaling system named ETCS for train control. So that's why the goals listed here are specific to both domains, signaling and telecom. The first goal was to test the coordination between all the railway domains in order to place the ETCS level 2 landside equipment, which are Orobalises and ERTMS marker. We have also the design of GSMR architecture in order to support the requirement for ETCS level 2. Third goal is to manage the interface between all the railway domains during the line of new telecom signaling cables, and also inside the railway right-of-way in order to find places where we can set up new technical rooms, outdoor shelters, or any kind of Kaizen element that should be located along the track. So in order to perform tests that are more accurate, this test case is based on a real infrastructure project. So it's the High Performance Marseille Ventimiglia project that aims to roll out the ERTMS level 2 between the city of Marseille and the city of Ventimiglia in Italy. I should mention that in this project, BIM technology has been adopted for the first time by SNCF in order to support the creation, collation, and exchange of 3D models during the detailed design phase for this project. But as you can see, the scope, the project scope is pretty wide. That's why we have decided to focus on a 16-kilometer railway line. So this is the railway line that connects the city of Cannes-la-Boca to the city of Grasse in the south of France. and all the data sets have been collected from this area in order to support the storyline test. Concerning the test team, it consists of domain experts from all the railway domains that belong to SNCF and also to RFI. Concerning the software vendors, there are two main software vendors that are actively participating. We have akka software from Italy and Rail Complete from Norway. There are also other software vendors that are participating as observers, like 12D Solutions and CGS Lab. Now I will go on to highlight the result that we have obtained. So this is one of the first results that have been implemented. As you can see here, we have an IFC file that include all the information related to the alignment, and along these three railway tracks that we have here, the ETCS level 2 lines and equipment have been positioned while taking into consideration the positioning constraints. We have also another example that shows the 3D representation of a radio station. So in our terminology, the radio station is named base transceiver station, and this is an example of the base transceiver station of Morgins, which is one of the 4 BTSs that have been implemented between the city of Kanlabuka and the city of Graz. And as you can see from the video, the geometry is very developed, and also all the specific properties have been assigned to the components of the BTS site. We have another telecom object with the specific requirement. So this is Ethernet network switch that has a certain number of ports. So the requirements related to the port is each port should be represented as an independent object that has its own IFC entities and its own properties and geometry representation. And as you can see here, all the communication ports that are located on the rear or on the front of this equipment have been well implemented. And for each one of these ports, we can define the specific properties. So I should mention that recently SNCF has invested a lot of money and a lot of effort in several improvements projects to restore its major railway line. So we have the project of HPMV that I have just showed you. We have also another project named High Performance High Speed Southeast that relates the city of Paris to the city of Lyon. So these projects combine all the railway domains and require powerful and efficient work methodology. That's why we need to embrace all the benefits of BIM. However, there are so many barriers to the BIM adoption. One of these barriers is to interoperability issues. That's why there are high expectations regarding the adoption of IFC in order to tackle this issue. So the current implementation results are proof positive that IFC schema will significantly improve the exchange of railway BIM models, which will assure the collaborative work activities between all the railway domains and all the project participants. So this reassures us that we can rely on IFC as the main interoperable information tool that will allow us to work together with other railway stakeholders, but also with all the external companies that operate in the rail sector, especially with the trend to outsourcing services. So that's it, and thank you for your attention.
Hello everyone, my name is Vincent Keller and I am the test leader of the Storyline Urban Railway Infosystem Integration. This Storyline is supported by French engineering companies and contractors for civil engineering and railway equipment. I'd like to thank very much Geodesial, akka software and RDF who carried out the test for this Storyline. The use case addressed are existing conditions, railway design modeling, interference and coordination management, and 3D visualization. Exchange scenario 1 is dedicated to the definition of a common spatial structure for an individual project. Indeed, infrastructure projects have to be broken down in several sites, and each site contains several types of facilities like road, railways, bridge, tunnel, buildings, and so on. Each facility has its own reference for the placement, local or linear, but at the end, one individual object should be located relatively to several facilities to be able to manage interfaces. This is an important condition to aggregate information in a digital twin coming from several IFC files. That's why we recommend to generate the common spatial structure at the beginning of a project in IFC and to initiate all the models in any software by importing the IFC file, including the common spatial structure, and then to update it during the development of the project. To carry out the test, Geodesial and Akka software developed a tool to generate the common spatial structure and then the IFC file including it. Each IFC facility part is defined by a unique ID, a type, and a subtype. The tool allows to declare and describe an interference between two facility parts by using the dedicated IFC classes. The geometry associated to the linear facility parts for the railways have been generated by using the concept of section swept area solids. It is an alternative of the BREP that generates a geometry based on the particular cross-sections that are usually generated by the authoring tools for linear infrastructures. It also includes information about the elements that support the geometry. This representation is necessary to use IFC for the design-to-design use case and is more accurate than the BREP representation and could be used by the surveyor to implement the project on site. For linear infrastructure, a geometry has to be associated to each facility part in the spatial structure, like it is the case for buildings. This geometry must include the information about the elements that are used for the local placement and also a representation of the spatial zone of each facility. During the storyline tests, Geodesial and Akka software provided IFC 4.3 files for parts of railway facility, road, bridge, and multi-duct utilities. Those files include the common spatial structure with interferences, the common spatial structure with geometry, the geometry for the linear facility based on alignments and sections swept area solids. Exchange scenario 2 is dedicated to cabling. This use case is very relevant to manage the infra and system integration, not only for a design phase, but also for a construction phase. It is also very valuable for managing these functions during the operation phase through a digital twin. I give now the mic to Peter Boonsma to present the test RDF carried out on import.
The Checkline Consistency tool can be controlled by a batch file. Each line in the batch file has 4 arguments: the IFC file, the HTML file generated, and the relative and absolute epsilon value. Running the batch file will return the HTML files. In this case, we see that the file from akka has perfect results. We did the same tests for geodesial. Also here perfect results from the test. The tools come with their source code, so developers can adjust or improve the tools.
Next step is to test the import and the use of the IFC 4.3 in a GIS.